Okay, so I recently got into some 3D printing. Think it's cool. It's all kinds of great stuff. Arduino's great. It's just fun hobby stuff. One of the issues that goes on with dealing with 3D printing is filament and its hydrophilic abilities to suck in water. And if you're trying to print and you've got basically you're melting plastic, it's kind of like burning wet wood. It pops and cracks, and next thing you know, there's all kinds of crazy stuff that happens. So you want your filament to be dry, and yes, plastic loves to absorb water. Well, there's all kinds of different things. Now, one of the things that I saw recently that brought this up was somebody was looking at doing a heated element for a bamboo, and I've seen all these little DIY projects on how to do heated elements for dehumidifying your filament, and you put it in a box, and you can do desiccant, and you can do this, and all these different ways to do it. I'm going to explain a couple of things because I just watched this one guy. He has an AMS system. It's an automatic material system, multicolor system for the bamboo printers, and in essence he's got a box with a bunch of spools of filament in it, and he puts this heater on the outside of it, and he popped a little hole, and he actually cut 2 holes in it. So if you were looking at it from the top, it would look like this. This is the AMS, and you would see the air getting sucked in through here. It got filtered. It was blown through with like a little PC fan, and then it came this way. It goes through the heat element, and it would go back into the AMS as hot air. So it draws the air in, heats it up, sends it back in, and heats up all the air and helps dry out the filament. The problem is that people, all he's doing is he is heating the air so that the air can hold more water, but he's just recirculating the air between inside the thing. It's like all you're doing is you might as well be just running a fan on the inside of the AMS. You're not really doing anything because the water's not actually leaving. You're bringing water in and you're taking water out. Sure, the air is capable of holding more water, so his filament was able to dry a little bit faster because now most of the water that was in the filament is in the air, but it's still in there. It's still in. As soon as he turns off the heater for the night or turns it off at any time, the water, where's it going to go? Right back into the filament. So, I mean, it might work if he was running the heater all the time and doing something like that, but what you have to do is you have to have an input and an output of airflow. And I'll explain. All right, so here's your AMS. You got your little filaments. If you look at any of the dryers, the dryers that you can buy on Amazon or whatever, I know they're expensive, whatever. What they do is they have an input of air that's coming from the outside. It comes in, it gets heated up, it goes in, and then they have an exhaust vent area where it comes out the other side, okay? I bought one of those I don't know what it is. It's an EOBOS, I don't know. It's an EIBOS filament dryer, and it's really kind of cool the way they built the little channels on it. But the air goes in here, and then it circulates over the filament, and then it goes out. What you're doing is kind of like what your air conditioner does when it has heat. You have air that comes into your heater, it goes across a heating system, and then it goes back. Well, what are you doing? You're grabbing heat energy and then you're sending it outside. You want to get rid of it. You have to get rid of it from being inside. You can't just sit there and just cycle it inside the house. So, what you want is you heat this air. Doesn't matter what the humidity is in your room. You're opening this up. Let's say the humidity is in this room and it's 50%. You're thinking that, okay, well, if it's 50% in the room and I heat it up, I'm just shoving 50% humidity into here. Well, technically not. What you're doing is you're taking air that is capable of holding a certain amount of water, okay? And the humidity is at 50% because that's how much it can hold. But what you did is you've created it and made it hotter. You need to stop thinking of it as it's 50% humid air you're shoving in, but what deficit of the air wants to absorb more water. By heating it, it wants the water. So granted, while sitting out in the room at 72 degrees, 50%, it's very happy to be 50%. But if you heat it up to say 108 degrees or 100 degrees, now I want to hold more water. I want to hold more. I want to be 75%. So it's a negative 25% of humidity that it wants to pull. It wants to grab that 25% of humidity out of here and take it with it out the door. Okay? That's what you're doing. You're trying to create that deficit by heating up the air. All right? So it's going to say, I want to grab the moisture, and then it walks out the room and it cools off and either dissipates into the other air molecules around, or it might condensate. There is an optimal theory, and you can try this if you want to. Obviously, if it's a space issue, it might not work. I'm not sure. If I was really trying to build the absolute coolest, fastest way to do it, this would be the way. There's actually, you could combine two methods, okay, of dehumidifying to cause this to be just out the door, dry that sucker fast. All right? The one way of doing it is through thermal cooling. Okay? And if you go on Amazon, you can get thermal cooling plates. And the way it works is that it has a plate where on one side you have one type of material, on the other side you have another. And what happens is this side, all the electrons want to flow to this. So it gets real hot here and it gets real cold here. Okay? When you put electricity in, that's what happens. It gets real cold and it gets real warm. And that's how most dehumidifiers in your house, like you go buy one, put it in the house, and it dehumidifies the house. It feels like it's getting warmer. Well, that's because you've got heat coming in from doing all this work, okay? Not to mention you're running electricity, which causes more heat, so you do kind of raise your temperature a little bit. But this cold surface acts the opposite of what I just described. Instead of wanting to hold more water, this cools the air and says, you don't want to hold that water anymore. You want to spit it out. So when you have a cold surface, like when you have an air conditioner or anything, they all drip from condensation. So, if you really wanted to do something cool, you would have a unit on the outside with this thermal piece. You would enclose it, okay? Let's say there's a wall here, wall there. You're looking at the airflow that goes over top. This is enclosed. You would have airflow coming in. It would come in, go across the cold plate. The cold plate would cool off whatever air is outside, causing condensation. So this air is no longer holding 50% humidity. Think about it for a second. So if it was 50% outside in the room, you would be dropping the humidity of the air below 50. Let's say because it's getting all drippy and whatever, it's getting to be 30%. We're going to be really boisterous here, or really braggy. Let's say we can drop it down to 35, 30, doesn't matter what number you're thinking of, okay? Let's say it drops it down to 45, whatever. You're dropping the humidity amount here. Then, again, have this enclosed, have a fan in the system somewhere where the air is getting drawn in. It then comes back across, you bring it across, you have it absorb the heat from this. So it reabsorbs the heat. And now, at 50% it was happy. You draw it across this, you drop its humidity level by letting the water come down and drip out. You have like a little tube or something, let the water drip out. Then you're heating the water, you're heating this air back up, and you combine it with one of the other heaters. So it comes down, it then comes back across. You have one of the other heater coils, so now it really wants to hold heat. So the water, let's say it was 50% when it comes in, and it's 72 degrees. It's going across the cold plate, it's dropping it down to say 65 degrees or 60 degrees, and it comes up and it's at 40% humidity. So 40% and 60 degrees, all right? Then it comes back here and it heats up again. So now it's at 108 and 40% humidity, but now it's capable of holding 75. And it wants 75%. Now you've lowered the amount of water in the air. You've raised it so it really wants to absorb even more water from there, and you shove that into your system. Now, that's kind of over-engineering and going overboard, but just some ideas. There's been a lot of guys working on ways of trying to get the humidity out of their systems. With the AMS, there's a couple of different systems that I've seen. I have a Bamboo and an AMS. And I don't like doing like huge modifications on existing, something I just spent like $350, $400 on. You don't want to just sit there and drill holes in it. Although these guys do, and they're all for it. But if I can get away with it without doing those kind of things and voiding warranties and the rest of that, I will. Couple ideas. Number one, okay, one of the problems they have is, and this would go on to also solving this problem as well. In the AMS, when the spools start getting real low on filament, they start rocking up and they get kind of tangled on the filament because the spool of filament isn't staying down. So what they did is they came out with these little cylinders and they weight them and they put them in the middle, and now it's going great. Well, in the lid, if you look at the AMS from the side, it looks like this, okay? And you're seeing down the center with the spools here. And so, very simple solution here. You 3D print, okay, because they love 3D printing. You open the cover this way. Let's say we open the cover and they've opened it, okay? So when you raise open the thing to change out the spools, you're opening it this way. This is the cover. So what you do is you have a rod that you can put in there and basically hold the spools down. So you can take and place a piece here and say, okay, now I can pull the rod out, I can pull the spools out, it's not a big deal, put them back, put the rod back, and it goes through. Why do I keep this open? Because now I've 3D printed a small triangle where I can put my little unit over here that does the air heating or cooling or whatever you do as far as trying to make it so it can draw out moisture. And you have that come up to here, go through on this side, and then on the other side you have an exit vent. But you 3D print yourself a nice little triangle that can sit like this and that can reclose on top. Here, you just expand the size. Instead of saying, okay, here's the AMS, you could sit there and say, okay, this is the AMS, and you could detach the lid from the hinge point that's here, the pivot point, where the hinge is plugged in, the little metal piece goes like this. So you detach it so it comes apart. You could make a square one with a new piece where you could reattach the hood, and now it's like this, and then you just have your heat element there, as well as a little cross beam or something to hold down the pieces. Anyway, there's your over-engineered idea on how to fix your Bamboo AMS so that you're working with an active heater. Good luck.